Good morning, good afternoon, good evening. Welcome to today's Siemens Global webinar. Today's topic we're looking at, realize a product's complete digital twin with model-based definition. I'm delighted to welcome as your two speakers today. We have Dr. Ken Verspreel, who's an executive consultant from CIM Data. His bio is up on the screen. I'll just touch on a few points and then we will be underway. We're also delighted to welcome Dave Wingrave, who's a product manager here at Siemens. Again, his bio is up on the screen. We just touch on a few points. Dr. Ken has over 40 years of experience within the application of computer-based solutions for engineering and manufacturing. He joined CIM Data after 16 years, heading up the design and creation and validation service for the CPDA. He has various threads of research under his bow, if you will, and spans geometric design, collaboration in terms of design, and automation. He also looked at PLM standards and openness and the integration of CAD across PLM applications. A very warm welcome to Dr. Ken Verspreel. And also we have Dave Wingrave. Dave leads the model-based definition solution in NX, and is responsible for defining the product vision, the strategy, and the direction. He has an incredible 25 years at Siemens in terms of our company, Digital Industries Software, and has worked for many customers around the globe in terms of multiple industries to optimize the way companies leverage the NX tool. He remains focused on ensuring the solutions he is responsible for provide significant benefit to customers, allowing them to achieve their productivity goals. So very warm welcome to Dave Wingrave. Without further ado, let's pass over to your first speaker today, Dr. Ken Verspreel.
Thank you for the introduction. I'd like to welcome everyone to today's webinar and to thank Siemens Digital Industries Software for inviting me to present this keynote address. Today's topic is PMI as a foundation for digital twin. PMI is, of course, product manufacturing information. If you will allow me first to make a short mention of SimData and the role we play in the industry. SimData is the leading strategic management, consulting, and research firm focused exclusively on PLM. We work with both providers and users of PLM technology to maximize their efforts to deliver products and solutions to the industry. We remain unbiased advisors in the PLM industry in that we do not sell or market any software or hardware solution. Our services are structured in the three main areas of research, education, and consulting. We offer our clients not only market research and analysis, where we publish market numbers by industry and by geographic area, but also support deep technology research in a wide range of areas such as CAD, CAE, data management, additive manufacturing, collaboration, and overall product development workflow. In education, we provide certificate programs in PLM, including detailed explanation of industry terms and the solutions currently available in the market. For consulting, we work with both solution providers and also industrial clients to help guide them through strategy planning, needs assessment, and product solution evaluation. As previously mentioned, my name is Ken Verspreel, and I'm an executive consultant at SimData, with responsibility covering the full product model creation and design collaboration workflow. I have deep technical experience in CAD and 3D geometric modeling. As an executive consultant, I work with both solution providers and industrial users. I've been with SimData since 2011, when the company acquired CPDA, or Collaborative Product Development Associates, the PLM spin-off of D.H. Brown Associates, where I held a similar PLM consulting position for over 10 years. Prior to that, I was with Computer Vision, one of the early CAD solution providers. In the 70s and 80s, I designed and implemented CAD systems. But I will let you read the slide details on my background on your own. Suffice to say, I have worked on the R&D developer side of CAD prior to my shift to consulting, and I have extensive experience in 3D geometric modeling since obtaining my doctorate degree from Syracuse University, where I studied under Professor Stephen A. Coons, who is considered to be one of the pioneers of computer graphics. And I've consulted on CAD over the past 30 years. For today's topic, I will begin with level setting the definition of PMI, followed by model-based definition and model-based enterprise. I will offer some key takeaways you hopefully will remember from the presentation. Then I will discuss the current state of PMI adoption within the industry on the technical side. Next, on to the business challenges driving the adoption of model-based definition with PMI. Then I will remind everybody of the PLM cycle so that we can plagiarize it actually, resulting in a PMI model-based definition implementation roadmap. We suggested some data for establishing model-based definition practices in your company. I will walk you through the 7 steps of the roadmap. And finally, I will make a few concluding remarks. Let's start with the definition of PMI. From SimData's definition, part manufacturing or product manufacturing information is data pertinent to manufacturing a product, including information such as tolerances, reference dimensions, datum points for quality processes, surface finish, material specifications, etc. This data has historically been included in 2D drawings to be used in manufacturing operations. MCAD solutions may also store the PMI in the 3D CAD model, from where it can be added automatically to drawings or accessed by viewing the 3D CAD model. Now, PMI has been discussed for years and is the foundation of model-based definition and model-based enterprise. So it is also the underpinnings of the digital twin and digital thread, without which we can achieve neither. As we move on to model-based definition itself, SimData defines model-based definition as the practice of using 3D solid models to document additional information about a design, such as PMI, the product and manufacturing information, including GD&T, surface finish and inspection datums, and associated metadata used in manufacturing. The PMI information is embedded directly in the solid models and is associated with the geometric elements of the design. It's important to remember that MBD includes PMI, but also semantic features. That is, machine-readable information about the product model's features that will help guide the part manufacturing process. SimData defines model-based enterprise as an integrated and collaborative environment founded on 3D product definition, detailed and shared across the enterprise, to enable rapid, seamless, and affordable deployment of products from concept through life. The foundational element of a model-based enterprise is the use of a configuration-controlled digital mastered dataset containing the 3D model and all necessary product data in a managed, secure, and controlled environment that supports maximum data reuse for all aspects of development, production, maintenance, and operations. I like to tell people that MBE is really model-based exploitation. You are using the PMI and MBD information to do a better manufacturing job, along with other downstream needs. I often warn clients, however, that as improved downstream apps do appear, they may assume PMI and MBD is in place. If you don't have it, you will not be able to take advantage of the newer apps. The presentation takeaways to remember are: 1. PMI is the foundation of model-based definition and model-based enterprise. It is the underpinning of the digital twin and critical information for the digital thread. 2, you need a strategy to implement PMI and MBD. One of the most common mistakes companies make is to use their traditional 2D drafting process, but now to do it in 3D. Problem is they do not correlate. For example, on a 2D drawing, a blow-up view is simply in 3D a zoom and save a view. Our third takeaway is to remember the technology continues to advance, and new PMI, MBD data items are likely to appear, as well as your CAD solution provider's reaction to them. You need to monitor and plan for that. So what is the state of the industry today with respect to PMI, MBD, and MBE? It's been a talking point for quite a while, but have companies been doing anything with them? Well, in the past year, we have seen STEP AP 242 Edition 2 approved, which contains a number of MBD advancements in the standards. The aerospace and automotive sectors, as usual, are leaders in the transition to MBD, but we are also seeing a major increase in others now adopting MBD. We do have experience in advising companies based on the experience of those leaders. This extends to advice also for the solution providers. Recently, the A&D PLM Action Group, administered by SimData, has published their minimum MBD requirements that include over 200 specific data items they look for. The group will be working with solution providers over the coming year to identify and close any gaps in their support of that PMI and MBD based on that list. Well, given the technology state, what is driving the efforts from the business side? Is your company reeling or dealing with the market pressures? It's what I like to call a tightening market, for what customer demands are getting more specific as product cycles speed up and product complexity increases. Are your companies reacting or just frozen from the pressure? Well, we at SimData, as well as others, emphasize digital transformation as the core solution for improving your company's way of doing business. We define digitalization as the use of digital technologies to change a business model and provide new revenue and value-producing opportunities. It is the process of moving to a digital business. It also provides the environment for defining the digital twin and digital thread. PMI enables digital twin behavior to be simulated, and it is the end goal of the digital thread, where digital values such as tolerances control machinery that makes the parts and products. So what should you do to adopt model-based definition with PMI? Well, let's take a lesson from the product life cycle. You've all seen some form of this so-called PLM swoosh, where product information flows from requirements all the way through to maintenance and repair, and finally product retirement. Let me plagiarize that PLM swoosh for our benefit. In planning and model-based definition with PMI roadmap, we begin with education, then developing a strategy and plan for putting MBD in practice. Next, implementation and validation, followed with communicating to downstream users the changes you are making with MBD and PMI. Finally, downstream exploiting those changes, but always keeping guard for updates. Now let's spend a minute or two on each of those. First step is to put together a transition team and educate yourself. You should really focus on 3 areas. Number 1, model-based definition and PMI concepts. The standards are presented in ASME Y14 series of standards and ISO Step AP 242. Number 2, learn in detail to support your CAD solution provider for supplies for PMI and MBD. Number 3, detail your company needs. What subset of PMI, MBD do you need for your products? For example, if you don't use composite materials, you don't need MBD items for composites. For those you do need, do the standards and CAD solution support them? What is the manufacturing and other downstream content you want to convey through PMI and MBD? You must then define a direction based on a strategy to implement and exploit MBD and associated PMI. What should the PMI for feature holes look like? And what data should they contain for leveraging downstream? What should PMI for fillets look like and contain? Systematically attack the varied PMI constructs, building your strategy along the way. Then plan and schedule their use by your design engineers. We recommend that your initial efforts be done as part of a pilot program. You really do want to avoid a big bang change in your workflow. Probably the most important aspect to the use of PMI with MBD is consistency. The PMI is data expected to be read by downstream apps. It needs to be in a stable form and content to be consumed by those apps. Simply telling your designers to create a PMI this way does not guarantee consistency. We recommend you use whatever tools are provided in your CAD solution to assist. And if you have the capability to do a software-driven check, since it's the validation process that will help you catch errors. Now, don't just throw new product designs over the wall to downstream organizations. Work with them to explain and highlight how MBD and PMI can help their work. Explore together those downstream apps that exploit PMI and semantic MBD. Now, your efforts in MBD and PMI are not one and done. The technology keeps evolving. Monitor the standards. Admittedly, they move slow, but they do move. Today, ISO Step AP 242 Edition 3 is being worked on, and we expect additions to MBD support. Also, work with your CAD solution provider that they may be planning enhancements in MBD and PMI, as well as new downstream apps that will leverage MBD and PMI. See where you can incorporate those changes in your implementation. And of course, validate your parts. So let me conclude by reiterating our original takeaways. PMI is a foundation of MBD and MBE. It makes possible the digital twin and enables the digital thread. When planning to do MBD with PMI, you need a strategy and an adherence to consistent implementation. Finally, expect that this is a continuing journey. Monitor enhancements to MBD and PMI and implement those that are beneficial to your business. Thank you.
Okay, great, thanks. As mentioned, my name is Dave Wingrave, and I'm the product manager for model-based definition. I'll provide you with an update on the latest innovations we're making in NX to help companies realize the true value of the digital twin, and show you how NX is transforming model-based definition both to make it easier and to create and easier to consume. I'd like to start by saying that Siemens has a long history of providing solutions to support model-based definition, and a rich history in providing innovation to support model-based definition. We were the first to deliver 3D annotation standards, 3D annotation solution to the market in the early 90s, and a decade before the 3D annotation standards were first released. We were also the first CAD vendor to proactively engage in 3D annotation and held leadership roles in both ASME and ISO standards and contribute to the development of those industry standards. Siemens has also delivered several industry-leading solutions to support model-based definition deployments across multiple industries. Model-based definition is strategic to Siemens, and we're committed to delivering innovative, high-value, high-quality solutions. The NX product includes solutions that address mechanical, automation, process, and electrical requirements. Model-based definition is a key component and contributes to the NX vision by providing solutions to capture and leverage information across multiple disciplines. A key pillar of our strategy is to deliver world-class engineering solutions by enabling you to build the richest, most comprehensive digital twin of your product. Model-based definition supports this by providing a rich set of data that defines a variety of characteristics beyond the size and the shape. So by including PMI, product manufacturer information, within the CAD model, designers and engineers can produce a complete digital definition of a product in an annotated and organized manner and ensure alignment throughout the production process. Our NX, our model-based definition portfolio is comprised of 3 solutions. The NX PMI application is a comprehensive production-proven solution and is recognized as a leading solution in the industry. NX model-based definition is a new solution that delivers advanced capabilities to support model-based definition deployments. I'll share some more strengths on this new solution in a moment. The NX technical data package solution is an easy-to-use, fully integrated solution for generating technical data packages directly from NX. The solution is supported in both native and managed mode and includes automation for batch processing. NX technical data package supports collaboration for suppliers, manufacturing, inspection, and quality, and really any others that require access to 3D content. One of the most significant benefits of model-based definition, as Ken mentioned, is the enormous potential for cost savings by leveraging and reusing model-based definition throughout the development process. And as Ken mentioned, this is referred to as model-based enterprise. And there's lots of examples in Siemens and Siemens partner solutions that support model-based enterprise for such areas as analysis, inspection, manufacturing, supplier collaboration, and others. So companies that are embracing the use of PMI and adopting a model-based definition strategy have seen the benefits in the area of time, cost, and quality by documenting information once and reusing it everywhere. So as I mentioned, we recently introduced a new NX model-based definition solution in the NX 1953 release, which was just in December. And NX model-based definition is an industry-first patent technology solution that delivers rapid definition and authoring of PMI with an emphasis on capturing key characteristics, knowledge, and company-specific business logic. The solution also includes a Pmi Advisor, which provides validation and notification for immediate verification that PMI is compliant with industry and company standards. NX model-based definition also focuses on direct consumption of PMI by Siemens and partner products, with new products being introduced in the NX 1953 release and beyond. With NX model-based definition, we're introducing automated authoring based on user-defined rules. The solution delivers over 30 out-of-the-box rules that can be used to perform common authoring operations such as applying a default tolerance, specifying multiple datums, creating size and locating dimensions, and many more. The solution also includes an interactive logic editor task environment that allows you to create and execute company-specific rules. Rules leverage topological feature recognition, so this enables support for authoring multi-CAD data, while also providing the ability to perform associative updating, which is a key strength of the solution. The solution really provides significant and measurable productivity gains that can really dramatically simplify the task of authoring PMI. As I said, the solution also includes a logic editor task environment. This is a powerful interactive diagramming interface that supports the building and executing of rules used to author and validate PMI. The solution enables you to produce automation to support your company's specific workflows and significantly reduce the amount of time to author PMI on your models. But NX model-based definition is more than simply authoring PMI faster. It's about capturing knowledge and intelligence that is consumable. So for example, today, authoring PMI on a typical CAD system for a number of holes on this part on the left-hand side would require manually adding 20 PMI dimensions. Adding to this is the requirement of selecting all these associative objects. Again, manual process of locating and selecting geometry for each hole size, and there are 90 occurrences on this particular example. Tolerance also need to be entered manually by ensuring that the values are the values are compliant with industry and company standards. The risk for error is a real possibility. I think you can recognize that. I should also mention that this is not exclusive to PMI, so producing a drawing would also take significant effort to and introduce additional risk if care is not taken. So with NX model-based definition, a rule can be used to locate holes on all the holes on the part. The NX model-based definition solution leverages topological feature recognition, as I mentioned, so you can quickly identify and capture specific hole types and sizes. The rules can also be used to access industry standard lookup tables for tolerances per hole type and size. And authoring the PMI size dimensions for all the holes in the part using a rule takes really only a few short steps. More importantly, the rule supports associative updates. So if there's changes made to the data, a simple update to the rule is all that's needed to provide that associative update. So this is just one of the many examples showing, how NX model-based definition, or NX MVD, will help capture key characteristics of knowledge. I mentioned that the NX model-based definition solution also includes a Pmi Advisor. So that the Pmi Advisor provides validation and notification for immediate verification that PMI is compliant with industry and company standards. The solution provides a number of unique capabilities, including multiple checking modes, allowing you to control the amount of feedback you receive. For non-GDT experts out there, the solution will advise on corrective solutions, making it easier for you to complete the task. And there's also a post-authoring HD 3D enabled solution capability that enables or allows you to have access to advanced visual feedback and reporting. So ultimately, the Pmi Advisor will help you to reduce costs associated with miscommunication and ultimately produce higher quality parts in less time. Just got a short little demonstration here to show you the automation. So in this example, you'll see that this is a single body. So this would be an imported data. There's no features in the model. You'll see in the reuse library, we've got a number of out-of-the-box rules, as I mentioned, 30 of them. So there's everything from feature control frames, dimensions, datums, model views, and so forth. In this case, when you kick off a rule, it looks very much like just a command in NX. So it presents a dialog to the user. They're prompted for information. In this case, we created a datum. But notice that the datum was across all the faces. So the system went out and found all the coplanar faces. In this example here, I'll add a positional tolerance by just identifying one of the rules out of the box. You could prompt the user for a number of different information, in this case a material modifier, select the datum, and it's going out and creating all of the PMI associated with that. In this case, it's live PMI, so in this case it found 28 holes. Remember, there's no features in this model, so very quickly and easily identified all of those, and then created all the positional tolerances. And these are just PMI objects, so if you look at the rules in the MVD Navigator, you can see all of the prompts that were presented to the user are also displayed and can be edited to update that information. I can also run the Pmi Advisor to find out whether all this PMI is valid. I can run this during or after. In this case, I'm running it as a post-authoring, and you can see there's a number of warnings. So if I look at those warnings, it talks about the material modifier as being not appropriate for this type of object. And so I can just make a change to the rule. It will update all the PMI that was generated with that And now if I just rerun the advisor, we can see that everything is valid. So this is just a quick example of something that can be done using the new NX model-based definition solution. So in summary, I guess I'd like to repeat what Ken shared earlier, and that is by facilitating a product's digital twin and digital thread, companies can accelerate the overall product development process and win market share. And the NX suite of model-based definition solutions deliver automation, validation, and consumption with significant innovation and measurable productivity gains. Model-based definition is strategic to Siemens, as I mentioned, and we're committed to delivering innovative, high-value solutions to support the transition from drawing-based workflows to help companies realize the true value of the digital twin. Thank you.